Hi, we're here today to perform a motor lead ID test. And we're going to talk about a dual voltage 9 lead Y connected motor. So here's what I know my windings inside that stator would look like. Right, a Y 9 lead dual voltage motor. It's meant to be hooked up in either a low voltage or a high voltage configuration, whether I put the windings in series or in parallel. And I've got some videos below which you can check out, description for those. And I also have this video again for a delta motor, which you can check out as well. But what we're going to do here is in a minute, we're going to grab a motor and we're going to grab a multimeter and we're going to go through the process. And the process is going to be fairly straightforward. The first thing we're going to want to do is we're going to want to identify our groups. You know, I have 3 groups of 2, 1 group of 3. From there, then we're going to want to perform phasing to ensure that this winding and this winding are wrapped around the same pole. So we're going to apply a voltage and do phasing. Then we want to confirm polarity. So we need to figure out whether this winding is this way or whether this winding is this way within that motor. And then lastly, once we've done all that, we're going to connect and we're going to energize that motor. So thanks for coming. Let's grab a motor and a meter and let's get started on. All right, so here I have my voltmeter using a Fluke 175 voltmeter. And I have a 9 lead dual voltage Y motor. So let me pull up my notepad here on the right and let's get going. So how do I know this is a Y motor? Well, first of all, to start off, I know it's a Y motor because like we see here, there's 1, 2, 3 groups of 2 and 1 group of 3. And that's using my ohm meter to identify that. Right, so that's what I want to start with. And that is actually going to be step number 1. Right, step number 1 is going to be to identify my different groups. So I'm going to start with that. So let's turn this to ohms, right? And of course here I've got 9 different test points, but we can imagine in the field I'm just going to label those 1 through 9 or A through I or whatever it is on my conductor while I walked up to this motor and it's not functional, right? So let's go through and let's identify those different groups and I will write those down. So I can see A to I and A to E. I also have continuity, which means that that's already my group of 3, A, E, and I. All right, so that's my group of 3. Now I can go through and just find all my groups of 2. Perfect. There's B and H is a pair. Oh. C and D is a pair, which should mean F and G. Perfect. So F and G is my 3rd group of 2. So now I've identified all those. So once I identify all my groups, what I can do is, because I'm not really concerned about the rotation or the direction of rotation of this motor, I'm going to quickly pick my group of 3 and I'm going to assign it. So I'm going to assign it A, E, and I to those 3 points, just like that. So I've picked those again. Mixing those up doesn't matter. That'll just affect the rotation, which is then going to put me to step 2, of course, which is phasing. Right, of course, with phasing, I'm doing the flux shower. So let's take a look at that flux shower. So what I'm going to do for this is I'm going to, of course, apply a voltage here to A and to E. In my case, I'm applying about 15 volts. Right, and that's going to rain flux through my stator. Now when I take my voltmeter and I measure here, I measure here, and I measure here, this winding and this winding because of the angle of cutting of the lines of flux, are going to see a higher voltage. And then my coil down here, which is parallel to my lines of flux, is going to see a low voltage. So let's take a look at that. All right. So let's take a look at that. So I'm going to apply a voltage, like I said, to A and to E. Turn my voltmeter to volts again and energize it. So I can double check. My source is, in this case, 15 volts. 15 works great, 20 works good, 24 works good, whatever works good for you, but it just has to be that low voltage because you never want the motor to try and spin. So I apply 15 volts to A and E. I'm going to measure around. So I've got my 3 groups of 3, so F and G. I measure 0.9 volts. Okay. B and H. I measure 1.9 volts. BH, 1.9 volts, write that down. And then last but not least, C and D, I measure 1.6 volts. So to me, it becomes obvious F and G, because I have that lowest voltage, is this winding down here. So this winding here is F and G. I'm not sure which one's F, and I'm not sure which one's G. I just know that winding is F and G. So I'm writing that down in my pencil. Once I write it down in the red pen, then it's permanent. Now I'm going to go around and I'm going to do the phasing on the other side as well. So I'm going to take off my 15 volts there, and I'm going to apply it down here. 15 volts to I and to E. Now this will be flux showering upwards like that. So I'm expecting a high voltage on F and G. I'm expecting a high voltage on one and a low voltage on one. So let's double check that first. So F and G we'll check just to confirm. I got 1.7, so that's a high voltage, so that's good. 1.7 volts. B and H measure 0.8 volts, so that might be the one. And C and D measure 1.9. Awesome. So that means B and H is my low voltage, which means B and H is this winding up here, the one running parallel to my lines of flux. So I will throw that up there. We'll call this B. We'll call that H. Again, not sure which one's B and which one's H. Now what I want to do is I want to do it probably a third time just to confirm that third one, but I'm pretty confident in this case, so I'm going to call this C and D. But if you're not confident or you're doing this for the first time, just run it the third time, connect your voltage to A and I, and double check. So that is step 2. Now we get into step 3. I'm just going to make all this a better color. So it is a little bit easier to read. Perfect. Now step 3 is probably the most difficult part. This is called polarity. So what we're doing here is we are ensuring that the windings all have the same polarity. So think about if I'm current. If I'm current and I come in down here at G, I need to flow the same direction through G and F as I do I through my center point. And if I don't flow the same direction, then those lines of magnetic flux aren't going to work together to make the motor spin. So we're ensuring that, this is F and this is G and not the other way around, right? So it's all about that polarity of how the current flows through those windings. So this is the trickiest step. So I'm going to walk through it. So in order to do polarity, so first I'll check F and G. So what I'm going to do is I'm going to apply a voltage. So I'm going to use the same voltage. I'm going to go 15 volts. I'm going to apply that to my group of 2 or to my outer winding. So F and G. Now my next step, I'm going to install a jumper wire. I'm going to install that from F to I. Okay, F to I, a jumper wire. F to I. And then I'm going to energize my low voltage. Awesome. So now what I want to do, now this is the part that hopefully makes sense. I'm going to take a voltmeter and I'm going to measure. All right, so that's my meter. I'm going to measure from G to either A or to E. So I'm going to measure to A. Now what we're measuring is this. So I'm applying 15 volts to this winding here. I'm putting it in series with another winding wrapped around the same core. If their polarity is the same, when I measure, I would have a positive polarity, so I'd get, maybe 18 or 20 volts. If the polarity is wrong, I would have a subtractive polarity, so I might get 10 or 11 volts, so less. So that's what we're checking. We're checking for additive or subtractive polarity. So I'm going to measure from G to A. So first I'll confirm my source is 15 volts. Now I'm going to measure from G to A, and I get 18.9 volts, which means it is a additive polarity, which confirms this is G and this is F. So confirmed G and F. Now we're going to do it 2 more times. You do have to do this 3 times. So I'll turn off my source, unplug all my conductors, and then take a look at my drawing again. So that's 1. So I'll get rid of that. Get rid of my jumper. Awesome. Now I'm going to do that on C and D. So I put in my jumper, C and D. I apply 15 volts. Or sorry, C and E is where my jumper goes. I apply 15 volts to C and D. Okay, so E to C is my jumper. I'm going to apply my voltage to C and D, and then energize. Now again, in this case, I'm going to voltmeter from A to D, right? Following the same idea here that if it's correct, my voltage will go up. If it's backwards, my voltage will go down. So I measure from D to A. I see 12.3 volts, which means my polarity is backwards. So, easy fix. So let's turn it off. I like to just unplug it all and start fresh. So that means, most likely, that this one is D and this one is C. But I like to confirm. So I've switched those two, D and C, I switched them around. Now I go from D to E, and I apply a voltage from D to C. And I'm going to measure the exact same spot as before. I'm going to measure now from C to A. Now I have 18 volts. I flip those two around, and I have an additive polarity. Awesome. So that's what you can see. We saw it both, right? We saw an additive polarity on the first one. Then on the second one, we saw subtractive. Once we flip those two around, in this case C and D, then we get that additive polarity, so we are good. So I'm going to do this one more time, just to make sure we're all on the same page. So step 1, B and A, I install a jumper. B and A, I install a jumper. Awesome. Then I apply a voltage, 15 volts, to H and to B. Energize my supply. Beauty. Then I'm going to voltmeter. Again, I can go from H to E, or I can go from H to I. It doesn't matter. I'm just measuring across those windings. So H to E. $11.84 volts. That tells me it's backwards. Simple fix. De-energize. I like to, again, like I said, pull it all out, fix my drawing. That puts B up here, H down here. Awesome. Move my jumper. Now it's H to A. Then I need to apply a voltage. I'm applying my voltage from B to H. Energize. Now I measure from B to E, and I have an additive of 18.56. Again, like I mentioned, you could also measure from B down to I, and it would work the same, right? So if I measure B to I have the same, an additive polarity, in this case 19 volts. Awesome. So now I've identified all of my terminals. So I'm going to turn off my power supply, unplug all my conductors. Beauty. Now step number 4, I'll get rid of some of this. It's perfect. So now all of my conductors have been identified. Step number 4, probably the most important step, is I'm going to connect and energize. So now this is where you need to know whether I'm connecting for a high voltage connection or a low voltage connection. This particular motor is good for 230 or 460 volts. So hypothetically here, I'm going to connect it for a low voltage connection, right, which would be a parallel connection. Oops, parallel. However, if you're looking for a high voltage connection, I have a video which I'll link above and of course below in the description. But in this case, we're going to do this low voltage parallel connection. And then we are going to run that motor and make sure it runs smoothly. So let's look at my connection. So when I'm doing a low voltage parallel connection, what I want to do is pretty simple. I want to create a second set of windings in a Y format. So I'm going to connect together D and F and H and F and D. So H, F, and D are all connected together at a Y point. So H to F and then F to D. So those are all connected together in a Y connection. I'm done with this meter for now. Right, so that's what I've got there. So I make that connection. Maybe I'll actually. And then what I want to do is I want to parallel this winding here, B and H, with this winding here. So what I'm going to do is I'm going to connect B to A. And I do the same thing along here, C to E and G to I. So I'll make those 3 connections. So B to A, C to E, and G to I. Now my very last step before I energize, of course, is I need to connect up line 1, line 2, and line 3. So again, line 1, line 2, line 3 is going to connect right in here. I'll use, come in with my green. Line 1, line 2, line 3, just like that. So line 1 to B, line 2 to C, and line 3 to G, just like that. And of course, my last step is I want to energize this to make sure it runs correctly. So let's take a look. Nice, smooth, and quiet. Now we can see this one is rotating that way. However, if my rotation was incorrect and I needed to change it, it's very simple. All I need to do is interchange any 2 lines. So I'm going to change around line 1 and line 3. And we can energize it again, and it'll actually run in the opposite direction. All right, so just interchanging any 2 of those lines will change the direction. So thank you so much for watching. Again, I'm going to have a couple videos pop up here about your low voltage connection and your high voltage connection, as well as your terminal identification. All of those are very, very important. If you are attempting this, in my classroom here, good luck to you. Take your time, spend the time, practice. If you're doing this out in the field, best of luck to you as well. Take care, have a great day, and thank you so much for watching.